Hi, everyone. We're the last presentation to go, and hopefully it will be the one you will remember. Okay, so we're going to talk about something called the Open Payments Cloud. It's been a project we've been running with a number of partners like Visa, some financial institutions, and this is, we're just about to go live with our first public beta at the end of this month. So we're going to tell you about where we're going with this and where we've got to so far. Okay. So, we've all heard about open payments, open banking today, and it's a really great time to be in payments. Payments businesses will start, are being created, and anyone who's created payments business in the past knows how difficult it is to do. But this time is going to be different. Already lots of public payment APIs out there from the card schemes, from some of the FIs, from some fintechs. The PSD2 legislation is going to basically force banks to open up, give access to account information and payment initiation services. And there are lots of non-bank financial institutions, BIN sponsors, card acquirers that are really looking out to work with innovators. So fantastic time to be in open banking. But maybe not so fast, right? Actually, payment API mashups are really hard. Any of you want to Google basically, distributed sagas, you'll see how difficult it is to try and control the consistency across and integrity across basically different transactions happening across different financial institutions. You try to match them up, things go wrong. There's no rollback, right? So it's actually quite hard work really making that stuff work. And PSD2 is great, but the third-party providers, which will get access to these APIs, have to be licensed. So there's already a bit of a hurdle there. And also there's all sorts of data requirements around the way you can get access to customer data. And finally, even when you have got your payment application, okay, PSD2 is going to give you certain levels of access, but you're still going to need to find friendly financial institutions that have got the right policies, right risk appetite, and right licenses to be able to power your payments business or your payment application. So it's going to be easier, but it's still pretty damn difficult to get a payment service, a payment application out there. Okay, and this is what the Open Payments Ecosystem project is about. It's what if we could bring together all those friendly financial institutions, all the APIs, all the third-party APIs, many of them the ones you've heard about today, KYC, currency exchange, bank transfers. What if all those APIs were put together in one single framework, and you could get something that makes it really easy for you to code across all of those, guarantee integrity, and just get on with building an application that out of the box is going to be secure, it's going to be scalable, it's going to have all those wonderful guarantees that we got from the HSBC team earlier today, and make it really easy for you to get your business up and running. So this is what this is about. And so if I had to pull out a few points on that, first thing is be able to combine all the different APIs into one single sort of fault-tolerant capability, be able to match your application, effectively publish your application in a kind of app store, and be able to connect it to all the participating financial institutions. You don't have to go running around trying to find willing financial institutions, because it will get matched up for you. And finally, by having a really intelligent sort of way of handling sensitive data, you can avoid being in scope with all the PCI compliance and PSD2 compliance when it comes to having to build your application, just making it much, much easier to build the right application. And so specifically, the Open Payments Cloud is not an API. It is actually lots of tools, and Brian will show you some of those tools, from the UX all the way to the business logic, and also connectivity into these FIs to build, deploy, and run your payment application quickly. We're talking about something that, instead of taking months, should take days and maybe weeks to run, a world-scalable application out there. The second thing is this is openly extensible. The framework itself can be extended by anybody. So any new third-party API can just be incorporated in the framework in a pretty open fashion. And also the Open Payment Cloud supports the concept of virtual private payment clouds. So if any bank wants to run its own little environment where they have their own developer networks, they don't have their own app store, they can also overlay a virtual private payment cloud on top of this sort of sea of microservices. That's what the Open Payment Cloud delivers. Okay, so Brian's going to take us through building an application using the Open Payment Cloud. You'll see a number of third-party APIs incorporated into what we call a payment model. This is the model that gives you all the stuff for free, all the integrity, all the security, and that's what the model does. And the application is built around that model. And then finally, the model is generating all the sandbox stuff, so you can test it. In fact, it's in a way a sandbox of sandboxes, because third-party APIs often come with their own sandboxes. And once it's tested, you can basically connect it to real financial institutions and have a payment service running. So that's what Brian's going to take us through.
Thank you, Alex. So we're going to have a brief look, right, at what it takes to build a payment application, right? And essentially what difference there is from building a payment application to building a traditional application. And in fact, there isn't much difference, right? So you typically start with a use case, as with any application. You have some problem you want to solve, and you go about trying to solve it. The main difference is what we call the payment model, right? And as you can see here, you have the traditional, some logic of the application, you have some interfaces, right, that makes your application. The difference here is that what the application does with money is described by this model. Right? As we can see from the graphic also, the model is built up of these little things. Now, what are these little things? So these components, right, that make up the model are what we call paylets. Right? It's a fancy word. That essentially means a component that can be used to build your model. Right? Now, there are three types of paylets. The first one we call the identity paylets, and they identify the owners of the funds in your application, right? So let's say you want to do business-to-business transfers. In that case, you would use the corporate paylet, right, to identify the types of businesses that would be participating. If you're doing something facing consumers, you would use the consumer paylet. If it's something B2C, you would use both, right? Now, the identity paylet, right, it represents the owners of funds, and it also allows us to essentially absorb all the APIs having to do with authentication, with identity verification, and with things like CRM, right, customer relationship management, where you can essentially build your application against these paylets and then plug in any service, right, any such service that you want. The second type of component is what we call the payment instruments, which represent where your funds will be held, right? So, obviously, money has to be held somewhere. It can be held either in your bank account, which we call external, right? So it's external to the control of your application. Things like, for example, external account paylet would identify the corporate or the consumer's account from which they get money, essentially. And there are other types of instruments which would be under the control of your application itself. And this is probably a big differentiator between what you can do with the Open Payments Cloud and what you can do with traditional APIs. Traditional APIs typically let you interact with existing accounts, but rarely allow you to provision new ones. Right? Through the Open Payment Cloud, you can actually provision accounts and cards. Right? And that's what we call managed. There are other types of payment instruments in the plan, right? Things like, for example, a cryptocurrency paylet, which would actually allow you to move funds from, let's say, from Bitcoin, for example, to a card, or from a card to Bitcoin, or do a bank transfer and send those funds using Bitcoin, right? Things like that. And also the cash paylet for interactions that actually start or end with cash. Like, for example, going to a teller, giving some cash to the teller, and actually getting those funds in a card, for example, right? You would be combining valid transaction. You would actually... All right, and the last thing is the transaction paylet, which is different ways, different patterns with which you can move funds around. Now, all these paylets have an API, they have an SPI through which we can connect third-party services, and essentially are the way with which, using these different types of paylets, you create mashups of third-party APIs. Now, I'm going to go through, I'm going to show you an application, and I'm going to go through essentially the steps we took to build this application. So this application is pretty simple. It is essentially, so I need to do this like this, but in principle, this is an application that allows a corporate to create cards. And the idea here is, let's say you want to reconcile the purchases that you do. The best thing to do is you create a card for every purchase or for every group of purchases. And this application allows you to do that. You can create a card, you can transfer funds to a card, let's say. Right, and you get the funds transferred, you can transfer funds back.
It's running live, right?
Yes, this is a live demo, thanks to the demo gods. It's working. It's actually connecting to the backend in the data center, but the actual application itself is running on my machine connected to the backend. Yes, and you can see the transaction history, right? And yeah, you can log in, etc. Right? So it's a pretty simple application. Now, in brief, it's a little hard to navigate, but there is a portal through which you can see all the data, right, that was created. Like, for example, these are the cards that I have been interacting with on the other screen. And also, so this is finally the API that I am consuming, right? So it uses the Swagger tooling, even for the documentation. So as an example, this is the managed cards Paylet, right? There's a snippet of part of the API, for example, to create a card. And since it's based on this open standard, we can use the normal Swagger tooling to generate code. Now again, I have to drag the my ID. So let me show you some code. So first off, this is the script that defines the model for this application without going into too much detail. This is the model for this application. We have a corporate, right, that represents the configuration of the businesses that will use this application. We have external accounts, through which funds would be deposited to what we call a managed card, right, which is an account managed by the application. And that's where funds sit until you need them on cards. The managed card Paylet represents the card that you create, right? And through the transfer Paylet, which is a pattern that moves funds between two managed accounts, you can fund the cards from your managed account and back. And through the withdrawal, you can remove funds from within the control of the application back to your account, to your external account. Right? So that is described through this script. Again, not going into too much detail, but this block here refers to the Paylet called managed cards. Again, there's something called profile cardinality. We don't have time to go into that much detail, but it has some information about the relationship and the constraints that you can apply. Now, if we look at the code for this thing, right? So if we look at here, right, this is some code. Again, it's a little unwieldy to manage it like this, but the call to the actual API, right, is a call to some code generated through Swagger. We're getting the information through an API that the UI calls, right, and just calling. So in a matter of about 8 lines, we can create a card. Similar thing with the other functionality, like, for example, getting the CVV for the card to show it on the screen, or showing the history, right? It's all of a couple of lines of code, right? In fact, all this code that you've seen is all the code there is to manage the cards in that application. And the same with the other parts of the application. Finally, some UI code. So again, I mean, some JavaScript code to define the cards component, right, using React and the UX framework which we build on top. And this connects to the backend using, again, some JavaScript that does the calls. And all of that together creates essentially the application that you've seen. So that's a very condensed look at how to build a payment application, right? And over to Alex.
Right. I don't have any time left, but I would say basically the tools include all the way from the UX, secure UX out of the box using actually an extension of the React framework. The business logic done through the payment model, which is defined by a very simple scripting language. And ultimately, it's a full life cycle from for building the application, then testing it and running it. As I said, the whole objective is something that would take typically months of work and really difficult failure handling to be done basically really quickly by using very simple tools where the heavy lifting is being done by a whole stack of middleware. If you want any more details of how that works, please come and talk to us. We'd love to have you on board for the public beta as well. Thank you. The concept of Paylet really applies to any sort of financial instrument and any sort of financial transaction. So there's nothing that stops the idea of having a wrapper around the idea of a security and actually have all the interactions being handled through this sort of Paylet payment model infrastructure. We haven't done it. It's not in our sort of roadmap right now, but there's absolutely no reason why that wouldn't be doable. Yeah, we see a couple of uses for the open payments cloud. One, it's any business that is involving a whole number of payment instruments. And increasingly, anyone who's providing solutions in the real world has to combine different financial institutions into a single program, different payment types. And basically, the idea is to make it really simple to do, but also future-proof. If you want to add more things, you can actually do it, and it's easy to accommodate change. The other bit is about the long tail, right? Really just making it possible for anybody, small business loan developers, to go and write banking-grade applications, not just front ends to applications, but actually quite deep applications for financial services. So those are the two really big use cases for us. Yes, so the UK faster payments, one of the paylets is bank transfer. So that allows you to make transfers between bank accounts. And basically, there is a connector that will allow you to take that paylet and make it work with faster payments. Equally, with a different connector, it would work with SEBA credit transfers, right? Or same-day ACH in the US. So that's the beauty of it. Once you've got the paylet, you build multiple connectors into actual real deployments of these services, and you're up and running. So there are two models. One is if you like, a banking as a platform model where we have partners, banking partners, and there we are building solutions, typically for very large corporates, and handling all those partnerships. And in that case, we're handling all the money and the costs and so on. And the other model we're looking to deploy is very arm's length, simply matchmaking and letting basically letting developers and the service providers really exchange, basically, revenue and obviously be charged fees.
Right, so I can take this one. Yeah. So data security employed. So we have two models, right? One where the application developer does not want to get licensed, right? Which is probably will be the typical one. The other one is if they actually want to be PCI compliant, for example, which means we just send the data as is. So for developers that don't want to be involved as part of the compliance part of the application, we tokenize the sensitive information. So when you actually call the APIs, you will get tokens, right? You will not get real cards, you will not get real CVVs. You'll get tokens, which you either send through as tokens to the API, which are then de-tokenized through a proxy if the client is calling the API directly, or they're tokenized in iframes on the UI if the caller of the API is a UI. Right? So the only place where the data is de-tokenized is in an iframe, which is directly between your browser and the OPC. The application never touches that type of data. Thank you very much.